Welcome to 6 Lessons Podcast. We're now in Season 4, Episode 6. Topic today will be biomimetic materials. How do you choose them? In dental schools, every dental school has a dental materials course. And the dental materials can go back to, obviously, amalgam and gold. Composites have been around for 50 years now. But the bonding materials and the materials that we use in the restoration have specific histories, and the choosing of a material should be based on successful applications. But the secret to biomimetic dentistry is that materials are important, but what's more important is how the materials are used. But for example, a material that's very popular today I would never use in a biomimetic restoration. That material is zirconia. Over the years, I've had many conversations with I would consider leaders in the biomimetic field, and they all come to the same conclusion. Zirconia is not biomimetic. Why? Because we know what a tooth is, and a tooth is connected side to side, top to bottom, and it has a hard outside, a soft inside, and we know how soft the soft inside is, and we know how hard the hard outside is. So we're trying to mimic that tooth. Well, if the outside of the tooth has a modulus of elasticity that's measured, and that modulus of elasticity is 60, 70 gigapascals, that's the measurement. But you have a material that the modulus of elasticity is 200 gigapascals. We say that's not like enamel, and it's not like dentin, which the modulus of elasticity is someplace between 12 and 18. And so if you put a very hard, stiff material and try to connect it to a soft material, there is a lot of movement, and that stress is at the connection between the hard and the soft. Now, a natural tooth has a difference in modulus of materials also. The modulus of elasticity of enamel, if it's 60 or 70 gigapascals, and we have much less, we have to have a strong connection as the biomechanics of the movement of the tooth are stressing that interconnection or that interphase, which we call the dentin-enamel junction or that dentin-enamel complex. And that's about 100 to 200 microns thick. But a natural tooth does really well under functional stresses. The top, it's stiffer, but there's a cushioning and a connection with that cushioning material that makes the top move in a very nice way and protects the bottom. Our good friend Wendell Robertson kind of likes to say it's like a football helmet. Football helmet's really hard on the top. The head, not so hard, but you have to have something cushioning that helmet to absorb the stress of a blow to the head. And that's the padding. If you have a hard top and a soft bottom, you have to have something in between that keep that connection working the way it should. And that is what the DEJ mimicking is about. The DEJ mimicking means that you have to have a material that is able to stay connected with a very hard material and stay connected with a softer material. And that's what's called the hybrid layer. Well, if you use zirconia, you get a very small connection, less than 20 megapascals bonding, and so you have a lot of stress onto a weaker bond. That's not what you want. You want to have something that is a gradient. You want to have hard on top, softer on the bottom, but have it have a gradient so there's not a stark contrast, a stark concentration of stresses from the hard when it gets chewed on. If that force goes right to that weakened hybrid layer, there's more chance of debonding. Well, that's the theoretical framework to understand why you would never want zirconia. Poor bondability and bad stress distribution into the hybrid layer. Well, this number that we talked about, the gigapascal number, which is the modulus of elasticity, it's also in engineering terms called Young's modulus. And the calculations of Young's modulus are what every designer of airplanes or cars, or even the eating utensils, the plates that you eat on, these are all things that every design of every material, modern material, takes into consideration. And so, what's an ideal enamel replacement? Something that is around 60 gigapascals. Ceramic is around 90, and so it's a little high, but it's not double or triple like zirconia. And the bond to ceramic has the ability to get into the 30 megapascal range, not the 20 like zirconia will max out at. And so if you have ceramic, then you have to make sure that you have a coupling with your next layer below it. And that coupling is called silanization. And so silanization or silane has the ability to make a ionic bond, and that ionic bond of the silane to the ceramic can be as strong as 30 megapascals. So that's high, but in my view, it's not high enough for me. I would like to maximize that bond so it's something more like the DEJ. And so if you have a silane to composite bond and it maxes out at 30, what's the DEJ? It's 50. That's the connection of the DEJ. So that's the silence that came from Urabe. Let's look at Urabe's paper. Just happen to have one up on the top shelf. So this paper is published in 2000. And when this paper was published in 2000, which is like 26 years ago, it confirmed many of the concepts that I was trying to pin down or trying to elucidate in 2000. The word biomimetic had not been really introduced into the dental literature aggressively. That came in 2002. But when I read Urabe's paper, I was already familiar with Tokyo Medical and Dental team of researchers. The name Tagami, I knew Dr. Sano, Dr. Nakajima. These are all friends of mine. Urabe was a graduate student. He didn't continue in the academic world, but we give him credit because he did most of the work to measure what the connection of the DEJ meant as far as strength of enamel to dentin. When I read that paper, I made a little note. This is the definition of biomimetics. It's important to examine the strength and structure of the teeth. The strength of tooth structure can be the true measure of the property of the restored tooth. And then they said this: novel resin bonding systems have high tensile bond strengths as well as cohesive strengths of the DEJ region. Accordingly, these materials have sufficient bonding performance regarding bond strength. Therefore, new principles for restorative restorations supported by adequate bond strength should be established. So what they were saying is that in 2000, we had been investigating for basically 20 years the bond strengths. And the bond strengths at TMGU with the bonding systems that were being developed by Urabe, different techniques and different systems, continued to approach that 50 megapascal range. Therefore, you don't need retention form. You don't need resistance form. Of course, these are dental concepts that were established by G.V. Black 100 years ago, more than 100 years ago. 2 volumes, 2 books published that gave the ideas of modern restorative dentistry. That was called modern then. That's not the joke, but it's like in 1910, you look back at what they were doing in 1810, and you go, man, that was savage. That's not modern. That's, anyway. But G.V. Black, the father of restorative dentistry, wrote 2 books. He used retention form, resistance form, extension for prevention, toilet form. That was a good one. Toilet means cleaning, so that was the 4th principles. There may be a couple others, but those are the 4 that stuck in my mind when I learned G.V. Black's system in 1975. But retention form and resistance form are now not needed because we are now sticking these materials at the same strength that the tooth is stuck to itself. We don't need to cut away tooth structure. The conclusion was, because we have higher bond strengths, we don't need retention form, resistance form. This is a total revolution of our overturning of the G.V. Black system. But the materials that we are using have properties, and those properties need to be evaluated in the framework of how does it compare to what a natural tooth is. And the reconstruction has to mimic what a natural tooth is. The traditional GV Black system never took any of those things into consideration. And so if we throw out zirconia, but we connect, or we include ceramic, we have to understand that ceramic has a limiting bond because of the silicization. That's the weak link. And so when I teach the 6 lessons approach, my preference is to use composite methacrylate systems. Now, the methacrylate systems, that's the polymerization molecule that is used. There are also dimethacrylate systems. What's the difference between a methacrylate, dimethacrylate? Dimethacrylate has twice as many double bonds to be polymerized. What does that mean? It means that the cross-linking is twice as fast. Is that a good thing? It's only good if you're thinking about the strength of the material that's withstanding occlusal forces, but not if you're understanding how a hybrid layer is formed. Again, these are advanced concepts, but if you're listening to this broadcast, it's because you want to get advanced concepts. So you need to understand that Beast GMA is a dimethacrylate. It gets materials stiff really fast. Do you want that in your composite that's restorative material? The answer is yes. But do you want that in the material that is mimicking the hybrid layer? And the answer is no. And so the hybrid layer mimicking materials that each have histories, and each have measurements, and each have experiments on them. There are actually 100 bonding systems that have been created in the last 40 years. When Bart van Meerbeek 20 years ago, or 25 years ago, 22 years ago, well, I'm missing a decade. 1993 to 2026 is like 33 years ago, right? Yeah. Oh my goodness. Where did that decade? What's 10 years more or less, right? But Van Meerbeek, when he tested the bonding systems in his PhD dissertation, 1993, there were 20 that were in competition for becoming marketable, profitable, and long-term sustainable. Those bonding systems, only 4 out of the 20 are still available for purchase. Whew. What does that mean? That means there is a natural selection in the marketplace. Dentists buy things that work better than things that don't work. But the 4 that are now in use are related to what we call the gold standard bonding systems. And the companies that make these should be very proud of it and should promote it. And they kind of do. But they kind of don't also. Why is that? Because dentists are so confused with what's going on in adhesive restoration to dentin that they are continually buying different products, looking for solutions to problems they have created from their technique. And the solution cannot come in the material. It can only come in using better materials in a better way. That's the secret of biomimetic dentistry. Materials are important, but they're not important as the technique. Well, let's just call that episode 6. In episode 7, we'll talk a little bit more about the materials in the bonding system, the material in the resin coating system, the material on the dentin replacement. We've already talked a little bit about materials on the enamel, but we'll talk more about them because each of those 4 materials that you're using have an impact on the longevity of your restoration. Till next time, stay bonded.